Welcome to this project. We will build a war card game in Python using object-oriented programming. So you will be able to apply everything you've learned so far to build a real game. This will be a simulation of the card game, implementing all the main rules. As an interesting tip, this game is also called Battle in United Kingdom. Let's review the rules of the game. The objective of the game, or goal, is to win all the cards. The player that wins all the cards wins the game. The deck that we will use is a standard deck with 52 cards. The possible values of the cards are Ace, King, Queen, Jack, and numeric values for the other cards, ranging from 2 to 10. In the program, we will assign the values 11, 12, 13, and 14 to these cards that are sort of like special in the deck. We will refer to them as special cards in our game, okay? This is a term that we will use in our implementation. We will need to assign them numeric values because we have to compare them to implement the rules of the game. Each card will have a suit. The possible suits in a standard 52-card deck are clubs, diamonds, hearts, and spades. We will have all of these cards for each one of the suits. Okay, we will also have two players, the human player and the computer player, which will draw a card automatically and play automatically. When the game starts, each player will receive 26 cards, half of the deck. Of course, the initial deck that we will use in the game, will be shuffled before the game starts, so the cards are located at random positions. Each player takes the top card from their deck on each turn. The cards that the player and the computer take will be facing up, so we will be able to see their value, description, and suit. The player who drew the card with the highest value is the winner for that round. In this game, suits are ignored, so we will only compare the cards based on their numeric value. The player who wins the round takes the two cards and adds them to the bottom of the deck. Now, if the cards have the same value, then the war starts. Both players take 3 cards, the human player and the computer player, from the top of their deck, and they place them facing down, so they will be hidden. They will also take 1 card, 1 additional card, and they will place it facing up. And we will make the comparisons based on the cards that are facing up. The card facing up with the highest value wins the round, and that winner takes all the cards that were drawn by both players. And the winner of the round after a war puts the cards at the bottom of his or her deck. They will be added to the bottom of the deck. If there is another tie, the process continues until one of the players wins the round. If one of the players wins all the cards in the deck, the computer player or the human player, and the other one has an empty deck, then the game stops and the player wins. And those are basically the rules of the game. Awesome! Please take a moment to analyze these rules, perhaps if you need to watch this video again, and try to identify the relevant classes that we will need to define, their attributes and methods. And you will find a written description of the requirements of the project in the next article. So, if you're ready, let's get started. Let's start writing our card game. First of all, we have to define the suit class, and this will represent a card suit. This class is going to have a class constant, which is going to be a dictionary, mapping the different suits to their corresponding symbols. Right now, we will go online to copy and paste the symbols right here. You will see how we will do that. But for now, let's just leave this as empty strings, so we can complete the dictionary. We see clubs, diamonds, hearts, and spades. These are the key of the dictionary. Now the values. If we go online to this article on Wikipedia, where it says standard 52-card deck, right here we can find the different symbols that we can copy and paste to our code. For example, right here, if I click Ctrl+C, or if I right-click right here and say copy, I can go right here to my code and click Ctrl B or right click and paste, and you will see that symbol appearing right here. We can add that realistic touch to our game. Let's do that with the other suits: diamonds, hearts, and spades. Like this. So we have all the suits and their corresponding symbols, and we can use those symbols in our program. To create a suit, we will need to know two things. We will need to know its description, and we will also need to know its symbol. But based on the description, which will be one of these four options, we can get the symbol from this dictionary. So we don't have to specify it as an argument. We say description and symbol. What will be the symbol? We have to take the symbol from this dictionary. This dictionary is a class attribute of the suit class. We write the name of the class, then we write the constant, and since this is a dictionary, we need to specify the key to get the corresponding symbol. And what is the key? Well, the description of the suit. We write right here description, and just to be really sure that the description is written entirely in lowercase, we can call this method lower to get a lowercase version of whatever the user entered as the argument. And we will use that in our code. Right here, we are assuming that the user entered a description, a valid description of one of these four suits, okay? So we have our two instance attributes. Each suit has a description and a symbol, and we will make them non-public because we only want to allow access to those values. We don't want them to be modified outside of the class because changing the description of a suit is not really logical, right? So right here, we are creating a getter for the description, and right here, we are going to create a getter for the symbol. Like this. Okay, so that completes our class. We have the class suit with a class constant that maps the suits, the descriptions of the suits, to the corresponding symbols. Right here, we have an init method to create an instance of suit with a description and a symbol. And right here we have the getters for the description and the symbol because we don't want them to be public, we don't want them to be modified outside of the class. Awesome, we have the first class of our project. In the next video, we will write the card class, which will be fundamental since this is a card game. Okay, so when you're ready, go to the next video, and I'll see you there. Now that we have our suit class, let's start writing our card class. Right here, you can see in my project structure that I've renamed the main.py file to suit.py because right here we have the suit class, and I created a new file called card.py. You can create a new file by right-clicking here, then selecting new and clicking right here, Python file. And then you assign a name to the file. Right here we have suit and card, so let's start writing our card class. First, we write the class header, and then we are going to define the init method. What is the init method going to do? Well, it's going to create a card instance, and we have to specify the suit and the value for that card. Those are the two main attributes of a card, the suit and the value. In this case, the suit will be ignored functionally in the game, but we will present it to the user to make the game more realistic. We set or define the suit as a non-public attribute, and we also define the value as a non-public attribute, because the card's suit and the value should not be changed outside of the class after the card has been created. What we do want to provide is a way to access their values, so we can create a getter with a property like this, and we can also create a getter for the value attribute like this, okay? We have the two main attributes of the cards defined right here. We also need to add right here above init a class constant. This constant will map or associate the values of the special cards to their descriptions like this: special cards. and that will be a dictionary, mapping the corresponding values to their descriptions. 11 corresponds to the jack, to the card jack. 12 corresponds to the queen, 13 corresponds to the king, and 14 corresponds to the ace. The ace is the card with the highest value on the deck for this game. Okay, so now let's start implementing our methods. We're going to implement a method called isSpecial. This will be a very helpful method to determine if a card is special or not. Remember that right here we are calling special cards the jack, the queen, the king, and the ace. I don't think that this is an actual formal term, but I'm choosing to name them like this in our program so we can differentiate them from the regular and common numeric cards that we can find on the deck. So we say isSpecial, and then we are going to return true if the value of the card is greater than or equal to 11. 11 is the first special card, which is the jack. And if it's greater than or equal to 11, then the card is a special card. After that, we are going to define a method that will be very helpful to present the data of the card to the user. The method will be named show, like this. We define the method, we're going to define it before isSpecial. And what are we going to do with that method? We're going to present the card to the user. It's like we're printing the card. How can we do that? First, we're going to take the value of the card. You will see why I'm doing this, of assigning this value to a variable right here in just a moment. But trust me that this will make our code more readable in this case. After this, we want to get the suit of the card. But we want to get the description of the suit, the string that describes it, like hearts or spades or diamonds, that kind of description. So what do? Well, we get the card suit right here, and since we defined the suit to be a particular object that we defined in our program, we can access its attributes. Like this. The suit has a description and it has a symbol. So we're going to access the description in this case, and we are going to capitalize that description. Right here, let's analyze what this line is doing right here. We are accessing the suit of the card. Remember that we are defining the card class. So when we use self, we are referring to the card instance, the card that we want to show. We take the card suit, and since the suit is a value itself, we can access its description because we defined in the suit class a description attribute. This property that we have right here can be accessed outside of the class right here. And after we have that description, this right here will be the description, we can capitalize it so we can present it in a nice user-friendly format. Great! So we have the value and the suit. We also need the symbol of the suit. We can define a variable suit symbol. And in that case, we just need to take the card suit and access its symbol. Remember that in our suit class, we also defined a symbol attribute, and we defined it as a property, a read-only property that we can access outside of the class. So that is precisely what we are doing right here. We are accessing the two properties that we defined in our suit class. Awesome! Now we have the three elements that we want to present to the user. And we need a conditional. Why? Because the presentation will be different if the card is special. If the card is special, like a jack, a queen, a king, or an ace, we don't want to show the numbers that we assigned behind the scenes. We want to show the description. For example, jack of diamonds or queen of spades. But if the card is numeric, we do want to present the number. So we say, if the card is special, right here we are taking the card instance and we are calling the method isSpecial. This will return true if the card is special. If that is the case, then we want to present the card description to the user, not the actual numeric value. We say card description, we're going to assign it to a variable. And how do we get that description? Well, remember that right here we have a class constant, where we mapped the numbers of the cards to the corresponding descriptions for the special cards. So we're going to take the value from that dictionary, card.specialcards, and the card value will be the key. We will take the value of the card and we will use it to get its corresponding text description. If we have, for example, a card with value 12, its description is Queen. So we use the value 12 right here as the key and we will get its corresponding description. We assign it to the variable right here for readability purposes, and you will see why in just a moment when we start writing the print statement. We start writing the print statement and we will use an F string. What do we want to present to the user? Well, first we need the card's description. If the card is special, we want to say, for example, Queen of Spades. Queen of, and then we present the suit, the description of the suit, as text. And after that description, we also want to present the symbol of the suit. Like this, okay? As you can see, assigning these values to individual variables right here really helped us to make this print statement more readable and understandable. Can you imagine trying to understand this print statement if we had not assigned this to variables before? We would have written all of this code right here directly on the print statement, and that would greatly reduce its readability. Okay, so now we can print special cards. So what happens if the card is not special and it's like any other numeric card on the deck? Well, we need another F string right here. And what do we want to print? Well, the card value directly because it is a numeric card. And then the suit, for example, 5 of spades, and then the symbol. And now we have our card class. That's really awesome, right? We've already defined suits and cards in our game, and we will work with them as objects. Let's go over this class one more time real quick to go over the small details and how these methods are implemented. We have the card class, we have a constant right here, a class constant, a class attribute, which is a dictionary that maps the numeric values of special cards, Jack, Queen, King, and Ace to their corresponding description. Then we have the init method with the suit and the value of the card. These attributes are non-public, so we create getters for them so we can access them outside of the class. We only define getters because we don't want to modify the suit or the value of the card after it has been created. Then right here we define a method to show the card to the user. We get the card's value, the suit, and the symbol that corresponds to the suit. We use right here the suit object that we will create from the class that we defined, the suit class. That object will have a description and a symbol. So we are taking those values and assigning them to these variables, which are used right here to print the data of the card and represent it in the game. Right here we have a conditional that checks if the card is special or not, because the output will be different for each type of card. If the card is special, so if it is either Jack, Queen, King, or Ace, we will print the card's description as text of the suit and then the symbol. Right here we are getting the card's description from the dictionary, the class attribute that we have right here. We will get the value of the card, and if it is a special card, we will get its corresponding description instead of the number. Right here we get the description and we use it in the output. Else, if the card is not special and it's just a numeric card from the deck, we print its value, its numeric value, and the suit and the symbol. And finally, right here we have a method called isSpecial, which returns true if the value of the card is greater than or equal to 11, if it is either Jack, Queen, King, or Ace. Awesome, now we have our card class completed. So we will start implementing our deck class. In the deck class, we will use both the suit class and the card class so we can start building the deck that we will use in our game. Take a moment to go over the code that we've written so far. Make sure that you understand it because we will be working with these two classes to write our deck class, okay? So when you're ready, go to the next video to implement our deck class. Welcome back. Now we will start writing our deck class. We have our suit class and our card class that we defined in the previous videos. Now, as you can see right here, I created a new file called deck. Right here, we are going to define our deck class and we will use both the card class and the suit class. So let's get started. First of all, we write the class header. We say class deck, and we will start by defining our init method. What do we want to do right here? Well, the deck can be initially empty or not. When the game starts, the human player and the computer player will have their own decks, but they will be initially empty. This is how we will represent it in our program. And for that, we will be able to tell the program if we want the deck to be empty or not. So we will assign a default value right here. By default, the deck will not be empty. But if we do pass the value true for this parameter, then the deck will be empty. You will see how we will implement this in just a moment. The deck will have an initially empty list of cards. This is very similar to our backpack class, remember. We have an initially empty list of something. In this case, it's cards. And we will fill that deck with the cards that we collect. Or we will have to build the deck to make a full initial deck for our game. You will see how in just a moment when we implement the build method. Okay? To create the cards, we will also need to create this class constant. It will be a tuple with the descriptions of the suits. Clubs, diamonds, hearts, and spades. We will use this to create the cards that will fill the deck when we build the deck. And we will also need to define a size property, like this. This is interesting. This is a special case where we are defining a property for an attribute that doesn't really exist right now, that we haven't defined right here. Why? Because we want that attribute or that property to be the result of another value. Let me explain what I mean. The size of the deck will be represented by how many cards it contains. So we will find that value with the length function, like this. So whenever we use the size property in our code, we try to access that property, we will actually be finding the length of the list of cards in the deck. That's really awesome, right? So we can calculate a property sort of like dynamically. When we use that, we will get the updated value of the length of the list of cards. Great, so now we have to define a method to actually build the deck. We have an initially empty deck, and if this value is false, we will have to actually build the deck and fill it with the 52 cards that a standard deck usually has for this type of game. So how can we do that? We define the build method right here with the def keyword and self. We are not going to take any arguments. And then, what are we going to do? We say for each suit in the list of suits of the deck, right here, deck.suits, and then for each value from 2 to 14, remember that right here, we have to write 15 because range doesn't include this final value. This will return a sequence from 2 to 14. For each suit in the tuple of valid suits, and then for each value in a range from 2 to 14, we will create a card and append it to the list of cards of the deck. How can we do that? We take the list of cards for this deck, right here, and we are going to append something to that list. What are we going to append? A card object. This is where things start to get really interesting, because we are going to create a card object and then we are going to append it to the list of cards, like this. We write the name of the class right here, and then we have to pass the necessary parameters. What does a card object need to be created? If we go to the card class, right here we see that it needs a suit and it needs a value. So the first parameter is a suit, but the suit is an object as well. We defined it right here. To create a suit, we just need the description of the suit. And right here we have it. We are creating a card for each suit. So this is the value that we have to pass. And the value is provided right here from the sequence that we create with range. you will see a red warning right here that says unresolved reference, card, and suit. This is because we have to give our file a way to recognize or to import those classes from other files, suit and card. We're going to write this right here. We say, from the card file, we're going to import the card class. And then from the suit file, we're going to import the suit class. Okay? You will learn more about import statements in a coming section of the course. You will see them in detail and all the different variations that you can use. But for now, we can use this right here. From the card file, import the card class, and from the suit file, import the suit class. And you can see that the red warning disappeared, because now we do have a card class and a suit class to work with. Awesome! Let's go over this method again so you can see how it works in detail. For each suit in the list of valid suits for the deck, we're going to create a card with each one of the values from 2 to 14. Remember that we have these cards from 2 to 14 for each one of the suits that we can create. So what do we do for each suit and for each value? Well, we create a card object right here with a particular suit and a particular value that we get from these loop variables. And then after we create that object, we append it to the list of cards of the deck. Self right here refers to the deck that we are creating, that we are building right here. Okay? So now that we have this method, we can build the deck. And when we create an instance of deck, if we didn't specify that the deck should be empty, we said that it shouldn't be empty initially. If this is true, if this deck shouldn't be empty, then what should we do? Well, we should build it automatically. We want to have an initially full deck with 52 cards. So this is what we are implementing right here. If we want to build a deck, then we just call the build method right here. This code will run automatically when we create an instance of deck because we are writing it in the init method. Awesome, we have this method already defined, so we have a few small methods that we also need to implement for our deck. For example, we might need to show the deck at some point, like this. So let's implement that method. We say, for every card in the list of cards, how can we show each card? Well, we call the show method of the card instance. For each card in the list of cards of the deck, we're going to show each card. And that is our implementation of the show method for the deck. We're just relying on the show method of the cards. This method that we defined right here for the card class. We can show the deck and we can also shuffle the deck. So let's implement this functionality, shuffle. We will need to import something called random. This is a module or Python file that gives us access to some functionality that we can use for random operations, like shuffling a sequence of items or generating random integers and things like that. So how can we shuffle our deck? We write the name of the module, and what are we going to shuffle? Well, the list of cards in our deck. Right here. We pass it as the argument. Random.shuffle, and within parentheses, the list of cards. Awesome. We can also draw a card from the deck, or take a card from the deck. How can we do that? In our simulation of the deck, right here, the list of cards is working sort of like a pile, like a stack of cards. This would be the bottom of the deck, and this would be the top of the deck. The first card in this list is at the bottom of the deck, and the last card on the list is at the top of the deck. So we have to take the cards, if we want to take them from the top of the deck, we have to take the last card on this list. And that is precisely what we will do to draw a card from the deck, like this. We say, if the list of cards is not empty, that is why we are writing this right here. If the list is not empty, this will be true. Then what do we have to do? Well, we have to take the last card in the list and return it. And that is exactly what the pop method does for a list. It takes the last element in the list, in this case the list of cards, and it returns it. And of course, it removes it from the list. That is exactly what we need. else if the list is empty, we return none. It is recommended to be consistent in our return statements. If we return a value right here, we should specify the value none right here to be consistent. And finally, we have our last method, which is adding a card to the deck. We will need to use this when the winner has to add the cards that he or she won to the bottom of the deck. Remember that we said that the bottom of the deck is the first element in the list and the top is the last element. So we have to add the cards, the new cards, to the beginning of the list. And how can we do that? Well, we take the list of cards and where are we going to insert the card? At index 0. Like this, okay? But in this case, we will need to take a card instance right here, a card object. We need to know which card we are going to add to the deck. And what are we going to do with that card? We are going to insert it at index 0 of the list of cards in the deck. Awesome, now we have our deck class implemented completely. Let's go over the class quickly one more time to make sure that you understand how these methods were implemented. We have our deck class, and right here we have a class attribute, which is a tuple with the 4 suits: clubs, diamonds, hearts, and spades. We define our init method with a parameter isEmpty to determine if the deck is empty or not. By default, the deck will not be empty, so we will build the deck when we create it. Immediately after creating it, the deck will be built with the 52 cards that we have to add. We also create an initially empty list of cards from the deck. This list will be populated if we decide to build the deck. But if we decide that the deck should be empty, it will remain empty. Okay? We also create a property for the deck class, which is the size of the deck. We are determining the size of the deck based on the length of the list of cards, how many cards the deck currently has. We will use this property, it will be very helpful to determine if the deck is empty or not. Okay? And we can also determine how many cards are in the deck, so we can present this data to the user in the game. After that, we define the build method, where we build the deck with the 52 cards. For each suit in the list of valid suits and for each value in a range from 2 to 14, we create a card with its corresponding suit and value, and we append that card, we add the card to the list of cards, to the top of the deck. Then we have a method to show the deck. For each card in the list of cards, we are going to show that card. Right here, we are calling the show method of the card object. This is the name of the method for the deck, okay? And this is the method for the card. We are using the method for the card in the method for the deck. They are not the same method, okay? This is not like a recursive call. They are different methods. And right here, we have a shuffle method which shuffles the list of cards. We are actually mutating the list of cards to make the cards be at a random position. We are using the random module to shuffle this list. We can also draw a card from the deck. Since we said that the top of the deck was the very end of the list, then we just pop the last card from the list, and that represents taking a card from the top of the deck. The pop method removes the card from the list and it returns it, so we can return it from the method. Of course, if the list of cards is not empty. If the list is empty, we return none. And finally, right here we have an add method where we specify the card that we want to add, and we insert it to the beginning of the cards list as the very first element, which represents adding the card to the bottom of the deck. This will be helpful for when the user wins the cards in a particular round of the game. Awesome, we have our deck class already implemented. Now we have to implement the functionality of a player. So go over this code and then go to the next video so we can start implementing our player class. Now let's implement the player class for our game. We already have 3 classes defined in their own unique files: card, deck, and suit. Right here, I created a new file called player.py. So let's start defining our class. We say class player, and then we define the init method. What do we want to specify about the player? We want to know the player's name so we can customize the output in the game. We also want to know which deck object is associated to the player. And we want to know if the player is the computer player, which by default will be false. By default, the player will be human. And if we pass the value true for this parameter, then the player will be the computer player. Okay, so let's assign these instance attributes: name, deck, and is computer. Okay, great, we have these 3 instance attributes. For now, let's define the name attribute as a public attribute. And the deck attribute will be non-public. We shouldn't change the deck that is associated to the object unexpectedly. So we make it non-public, and this attribute is computer should also be non-public because it shouldn't be changed outside of the class. This shouldn't ever change after we create the player. The human player cannot become the computer player or vice versa. Great, we have the init method. So now let's define a property. We will define a property for isComputer for this attribute. This is the getter, we write isComputer right here. Now we will define a short method that will return true or false if the deck is empty or not. This method will be called hasEmptyDeck. Okay? And what are we going to return? Well, we're going to return true if the size of the deck is equal to 0. The size of the deck associated to this player, this deck that we defined right here. We are associating a specific deck object to the player. So if the player's deck, like this, is empty, so if its size is equal to 0, then we return true. And this is exactly what we get from this comparison. If that is not the case, then we return false. And we can write the method like this with just 1 line. Remember that we created a size property in our deck class. If we go to our deck class right here, we see the size property that we defined. This is how many cards the deck currently has. So we can use that property right here in our player class to check if the player's deck is empty or not. Awesome, we just have 2 methods left to implement to complete our player class. We have the method drawCard, because we want the player to be able to draw a card from the top of the deck. We say if the player's deck is not empty, so if it's not the case that the player instance right here self refers to the player, has an empty deck, this is the method that we implemented before. This will be true if the deck is empty and false otherwise. So we are negating that value and we're checking if it's not empty. If that is the case, then we just draw a card from the deck. Like this, okay? We take the player's deck that we have right here, and that deck has a method called draw. We defined it right here in our class deck. If we go right here below, we see the method draw. This method draws a card from the deck. So we are drawing a card from the deck associated to the player. Else, if the deck is empty, then we return none. Great! We can draw a card, but we also need to add a card to the deck that is associated to the player. Because if the player wins the round, he or she will have to add the cards to the bottom of the deck. So how can we do that? Well, we say add card, and we have to know which card we are going to add. This will be a parameter. How can we implement this method? Well, we take the player's deck, and we add the card. Like this. The deck class has an add method. If we go to our deck class, we can go to the very bottom of the class and we will find the add method for the deck. This adds a card to the bottom of the deck, so this is the method that we are calling right here. We're taking the card that we want to add and we add the card to the deck that is associated to the player. Okay? We can also check if the deck actually exists, if it's not the value none, if the deck is a real object, okay? Okay, right here we are assuming that the deck will always exist, okay? It will not be the value none and it will be a valid deck object. Awesome, so now we have our player class defined. We have our class constructor with the name, the associated deck, and an attribute to determine if the player is the computer player or not. By default, it is not the computer player. Then we create a property for isComputer, and we have three methods. HasEmptyDeck, which returns true if the deck is empty, if the player's deck is empty. Remember that we are defining the player class, so we are checking if the player's deck is empty. We can also draw a card from the player's deck, and we can also add a card to the bottom of the deck. Awesome work! Now we have our player class. So we're almost done with our game. We just have to implement the War Card Game class with all the main logic of the game and the main logic of the game in the program. When you're ready, go to the next video, but first, make sure that you understand how this code works behind the scenes and why we are writing each line of code in the methods. Review the code for suit, card, deck, and player, okay? And then go to the next video. I will see you there. Okay, so let's start implementing our War Card Game. This will be a class where we will define the main functionality of the game, and we will use the class in our main program to make the game actually start and work. First, we have to start with the class header. We call this War Card Game. Okay, and what do we want to specify for the game? What do we need to know to make a game instance? Well, each game has a player, a human player has a computer player, and it has an initial deck. So these are the three values that we will have to specify to create a War Card Game. Each one of them will be a non-public instance attribute, because they will not change during the execution of the program. Each game will have an associated player, computer, and deck. Great, we have our init method so we can create game instances. But when the game starts, we want to make the initial decks. Remember that when we covered the rules of the game, we said that initially we had a deck with 52 cards. But we had to shuffle the deck, and then we had to make new decks of 26 cards for each one of the players. So let's do that. We're going to define a method called makeInitialDecks, like this. This method will be in charge of making the initial decks when the game starts. What do we have to do before making the decks? We have to shuffle the deck. So, how can we do this? We can take the deck associated to the game and call its shuffle method. Remember that right here in the deck class, we have a method called shuffle that shuffles the list of cards in the deck. So that is exactly what we are calling right here. After we shuffle the deck, we have to make the player's deck and make the computer's deck. So we are going to call a method that we haven't defined yet in our class. It's called makeDeck. And we will make the deck for the player, and then we will make the deck for the computer. Don't worry, this is yellow right here because we haven't defined the method yet, but we will do it in just a moment. Right here, we are going to start defining this method, makeDeck. What are we going to do? Well, we are going to take a particular character. I'm referring to this as character because I'm using a generic or general way to refer to a particular character of the game, the computer player or the human player. So to mention them in a general way, because this can apply to either one of them, I'm just naming this character. For that specific character, we are going to take or draw 26 cards from the deck. So we are going to create or write right here a for loop that iterates 26 times. Each time we are going to take a card from the deck. And how can we do that? Well, we write the name of the deck right here, and then we draw a card by calling the draw method of the deck. If we go again to our deck class, we can see this method right here, draw. To draw a card from the top of the deck. We take the card, and then what do we do with the card? Well, we are going to add the card to the character that we specified. If this is, for example, the human player, this will add a card to the human player, this card that we drew from the deck, right here. Remember that in our player class, we had an add card method. Right here we have our player class, and we have an add card method that we can call to add the card to the player's deck or to the character's deck. Great, so now we have the first building blocks of our class. We have the init method to associate a player, a computer player, and the deck to a particular instance of the game. And we can also make the initial decks by shuffling the deck and by making the deck for the player and for the computer. We can make the deck by drawing 26 cards from the deck associated to the game, the initial deck that we will use in the game, and then we can add each one of those cards to our character. But we have just one small line right here missing. When we create a game instance, we want to make the initial decks immediately. We want to shuffle the deck and make the individual decks for the player and for the computer. That is the first step of the game. So we can do that automatically by calling makeInitialDecks right here on the init method. I'm just separating this with a blank line so we see that right here we are defining the attributes and right here we are calling a method. Awesome! Now we have this part of the class implemented. In the next part, we will continue implementing the logic of the game for the battle and the war. So go over this code, make sure that you understand it, and when you're ready, go to the next video to implement this part of the code. Okay, so we're back to our word card game class. Now we will implement some new methods to make the functionality of our game come to life. Particularly, we will start with the start battle method. This method will be key. In this method, we will implement the actual logic of the game. In this type of card game, we have two different stages, a battle and a war. The initial stage is a battle when the player and the computer draw two cards, and if one of the cards has a value greater than the other one, then that player wins. But if there is a tie, then we have to go to a war. So we will implement those two stages as separate methods, battle and war. They will actually be like a cycle, because the process repeats itself if there is another tie, and the battle continues, and then there is another war, and possibly we could enter a cycle. So from that cycle, we could have some cards that come from the previous stage, which could be a war. By default, this will be none. If there are no previous cards from a previous state of the game, then this value will be none. But if there is a sequence of cards that we had won from previous steps of the war, then we have to pass them as arguments right here to continue the cycle until one of the players wins all the cards in that round. Awesome, so let's start the battle. First, we are going to print a message. 1, 2, and we're going to say, let's start the battle. You can customize this to your liking and print the message that you would like to show the user when the battle starts. Now, what happens in the real game when we start a battle? Well, first we get two cards. One card from the player and one card from the computer. Each one of them draws a card from their corresponding deck. So let's do that. We're going to get a player card, which will be taken from the player's deck. Remember that the game has a player object associated to the game. This is the human player. So we can use that object to call the draw card method. This method was defined in the player class right here. It draws a card from the player's deck. So we will get that card object. And we can do the same with the computer player. Computer, and then we call draw card. Remember that the computer player is also a player, so they both have this method defined. Awesome, we have our two cards which will be facing up. What is the next step? We have to display both cards. So let's print it like this. We say your card, and what are we going to do? We are going to show the card drawn by the player. This is a card object, and we know that in our card class we defined a show method to display or to show the user the value, the suit, and the symbol of the card. So we can call that method right now. And then we are going to show the computer card. We take the computer card and we call the show method right here. So we are going to display the data of these two cards so the user can see which card actually won the round, the card with the highest value. Right here, if you are curious about these symbols that I'm adding to the strings, these represent new lines. This is because we want to separate the output and create new lines between the different messages, so the output doesn't look cluttered and full of text, okay? You will see how this looks in the final output. After we have those two cards, we just have to know who won the round. And for that, we have to compare the player's card and the computer's card. Which card has the highest value? Well, for that, we are going to implement a new method, which will return the winner of the round. That method will be called getRoundWinner. We will implement it in just a second. But the method will take the player's card and the computer's card. It will compare them, and it will return a code or a value that will represent the winner of the round. And we will also need to get the cards won by the winner of the round. Like this. We will define another method called getCardsWon by the player or the computer player. We pass the player's card and the computer card because these two cards will be won by the winner of the round. But the winner can also win previous cards from previous phases of the game. If we have a cycle where we had a battle and then a war, and we had another tie and we had another battle and another war, the process continues, and we accumulate all of those cards until one of the players wins the round. So those accumulated cards will be these ones right here. These cards would also be won by the winner of the round. So these two methods will have to be defined right here below. But before we define them, let's see what we do with the winner. How are we going to know who won the round? Well, we're going to use particular numeric values to identify them. These values will be returned by this method. The values will be these ones right here. We will identify the player with the value 0, the computer player with the value 1, and if the output or the result of the round was a tie, we would get the value 2 right here. We will define these as class constants because we want to make our code more readable. Instead of using the values directly and compare them in our conditional, we want to add some meaning to those values. So we add them right here and we define them in the class. You will see how this works in just a second. We say if the winner of this round is equal to the code of the player, the code that we assign to the player, we will have to write it like this because this is a class attribute, a class constant. We write the name of the class followed by the name of the constant using dot notation. If that is the case, if the player, the human player, won the round, we would print this message. You won this round. And what are we going to do if the player won the round? Well, we will add the cards to the character's deck. Which character? Well, the player. And we will add all the cards won by the player. This is another method that we will define right here below. We're just writing sort of like the general structure of this method, and then we will implement these methods that will make all the functionality come to life. This is what will happen if the player wins. Now, if the computer player wins, then we will have to compare this against. We say if the code that we got for the winner is the code that we assigned to the computer, then the computer won this round. And we should print this message. The computer won this round. This time we're not so happy, so we don't add an exclamation mark. Again, we say add cards to character. Which character? Well, we are going to write this the computer character, and we're going to add all the cards won by that character. Else, if neither the player nor the computer won the game, then it's a tie. And we have to print a message like, for example, it's a tie, this is war, because now war will start. Remember that in that round, the player and the computer take 3 cards which are hidden, and they take another card, and that is basically what the war is all about. Right here, we're just implementing the basic round, which is the battle. If that is the case, if there is a tie, then we have to start the war. And we are going to pass all the cards that would have been won by the player if the round was not a tie. We still have to accumulate those cards for when one of the player wins the round. Okay? So this is the basic implementation of the battle, the start battle method. We have a print statement to start the battle. We draw two cards, the player card and the computer card. Then we show the cards. We get who won the round from this method that we have to implement. Based on the player's card and the computer card, we will compare their values. We will also get all the cards won by the player. The player's card, the computer's card for this round, and also all other possible cards that we might have accumulated from previous battles and wars before a player won. And we say, if the winner, right here, this will be either 0, 1, or 2. One of these codes right here. One of these sort of like codes that we assign to each one of these characters, player, computer, or if it's a tie. So we say, if that value is equal to the value that we assign to the player, we print a message and we add the cards to that character. To the player, we add all the cards won for that round and for any previous rounds that were still pending to be resolved. Else, if the winner was the computer, we print this message and we do the same. We add the cards and the previous cards. If neither one of them won, then it's a tie, so the war starts and we start the war, passing the cards that would have been won in that round. Finally, we also have to return right here the winner. We will return the winner, the code that corresponds to the winner, from calling this method right here. Awesome, so let's start implementing these methods. Let's start by implementing getRoundWinner. How do we know who won that particular round? Well, let's see. getRoundWinner. We will need to take as argument the player's card and the computer's card. We will compare them based on their value and determine who won. So we say, if the player's card, if the value of the card is greater than the value of the computer's card, then what code should we return from this method? Well, we will return the player's code. Remember that we are working right here with these class constants because we want to add meaning to our code. If instead of returning this, for example, we would just write its equivalent code, return 0. That really doesn't tell us anything about what we are returning, right? So by creating a constant for this value, we are assigning meaning to our code and we are making the code more readable. We know that the player won the round. Else if the value of the player's card is less than the value of the computer's card, then that means that the computer won. And we return the code that corresponds to the computer. Else we would have to return the code that corresponds to a tie, because this round resulted in a tie and we have to start the war. Awesome! We have our first method. Now let's implement the second method, getCards1. This method should return a list of all the card objects that were won by the winner of the round, or that the player should have won if the result was a tie. We would have to combine the player's card, the computer's card for that round, and all the previous cards that were accumulated from previous rounds. The result should be a list. So let's implement this method, getCards1. We would have the player's card, the computer's card, and all the previous cards. We can name this parameter like this, previous cards. So we say, if there were previous cards, so if this list is not empty, then we will have to return a combination of the player's card, the computer's card, and previous cards. Why are we writing this like this? Let me explain. The player's card and the computer's card are objects. They are card objects. So we are making them right now elements of a list. But previous cards, this parameter is a list of previous cards, of card objects. So by concatenating or joining these two lists, we're creating just one list with the previous card objects and the new card objects. And the result will be a list with all the card objects that could be won. Great. Else, if there weren't any previous cards, then we just have to return a list with the new cards, the player card and the computer's card. And that is how we can implement this method. We just return a list with all these objects. This name should be cards, okay? To match the name that we wrote right here. We have to add an S right here. So we've implemented these two methods. Finally, let's implement this method in this video, and then in the next video, we will implement the start war method. Add cards to character, okay? Add cards to character. What is this method going to do? Well, this method is going to take the character that won the round, and it's going to take a list with all the cards that the character won, either the player or the computer. And it has to add those cards to the player or the computer's deck. So let's implement this functionality. It will have to take the character as argument and the list of cards. And then we say, for each card in the list of cards, then we just have to add that card to the character's deck. Remember that character is of type player. So we have a method called addCard that adds the card to the deck. And that is basically the implementation of these three methods. Awesome work so far. We've already completed the implementation of our war card game. We have our init method, we make the initial decks, we start the battle, and we implement the main logic. We can get the round winner, we can get all the cards that were won by the player, and we can add cards to the character's deck. So, the method that we are left to implement right now, and some other smaller methods, are start war. We have to implement what happens when there is a tie in the round, when the two cards have the same value. We will do that in the next video. Go over this code and make sure that you understand how it works and why we write each line of code in the implementation. After this, go to the next video so we can complete the implementation of our class. Welcome back. We're back to our war card game. And now we have to implement what happens when we have to start a war. Right here we see a warning because we haven't implemented what happens when there is a tie. So let's implement that. We have to define the method start war. This method is going to take one argument. So we have to define one parameter. That parameter will be the list of card objects that we got from the battle. The battle is the first round when we draw two cards. If there is a tie, then we start a war. But those two cards still have to be accumulated for when the player or the computer win the round. So we will take them as an argument right here. During the war phase of the game, the two players draw 3 cards from their deck, and these cards remain hidden, but they are accumulated for when the player wins the round. We're going to define a player cards list, which will be initially empty to keep those 3 cards that we draw from the deck. And we will also define a computer cards list for the same purpose. After that, we have to draw 3 cards. So we're going to write a loop. In that loop, we're going to draw a card for the player from the player's deck, right here, using the draw card method. And then we are going to draw a card from the computer's deck with the draw card method. We have the 2 cards that we draw, and then we have to add that card to this list. This list will contain the 3 cards that we drew from the deck for each one of the players. Right here, we are just drawing 3 cards, one for the player and one for the computer, and then we are appending them. We could also write these lines like this. We take the player's card and then we append the card to the list. We take the computer's card and then we append the card to the list. After we have that, we have 2 lists with 3 card objects for each one of the characters. We will print this message for the user. 6 hidden cards. So we will represent them with an X. This is just to add some interactivity for the user to show that we drew 6 cards and they are hidden. So after we have the war, after we started the war and we draw those 3 cards, the functionality is basically the same that we implemented for a battle method. We have to draw 2 cards and then compare them and determine which player won. So that is basically what we wrote in Start Battle. Therefore, we can just call the Start Battle method again, like in a cycle. And what are we going to pass right now to this method call? If we go to Start Battle, we see that we have an optional parameter, an optional argument right here. The cards that we got when we played the war. By default, this is none, in case there wasn't a war before we started the battle. But if there is, like in this case, we can pass that list with all the cards. So we will do that. We will pass the list with the 3 cards that we got from the player, and the cards that we got from the computer, and all the cards that we accumulated from the previous battle. Remember that when we start the war, we had previously another battle. So those cards should also be accumulated so the winner can take all the cards. We concatenate these 3 lists. These 3 arguments are lists, and by using the plus operator, we can concatenate them to make a single list. This will be the argument to start battle, and the cycle will continue, accumulating cards until the process stops because one of them has a higher value than the other. Great, we've implemented start battle and start war. Awesome, so we have our start war method implemented. And it works in a cycle with the start battle method. One calls the other and the other one calls the other until the process ends. When does the process end? Well, when we have one of these cases. When the winner is either the player or the computer. You can see that in these cases, we don't call the start war method again. We just call it right here when it is a tie. Please take a moment to go over this code again to understand how we start the war and how we continue the process, and how the parameters are working behind the scenes. When you're ready, go to the next video to implement 3 small methods that will be very helpful. So we'll see you in the next video to start implementing this code. Welcome back. Let's start implementing those 3 very helpful methods that will make our game come to life. First, we have to check if the game is over. And how can we do that? Well, we said in the rules that the game ended when one of the decks was empty. So the other player won all the cards in the deck. We have to check if one of the decks is empty. For example, if the player's deck is empty, like this, then the game is over. That's right, we have to end the game. So we will return true right here. We want this method to return either true or false, if the game has to end or not. If the player's deck is empty, then that means that the computer won. And we should print a descriptive message, a nice message to tell the user the result of the round. We say, we see game over, and then we see try again, the computer won, or the computer won the game. You can customize this message. After we print that, we can return the value true. You can add a blank line or just leave it like this without a blank line. But what happens if the computer's deck is empty? If this is true, then we should also print game over, like we do right here. We can copy and paste this. But now the message will be different because the player won. In this case, we're going to use an F string because we're going to customize this with the name of the player. We're going to say, excellent, you won, and then the name of the player, like this. Congratulations. And right here, we also have to return true because the game is over. One of them won. Else, if this is not the case, if neither the player nor the computer has won the game, then we just return false to tell the program that the game is not over yet. We will use this method to determine if a while loop has to continue running. So that is why we return either true or false. Let's also define a method that will be very helpful to create the user experience during the game. Print stats. Print statistics. What are we going to do right here? We're going to tell the user how many cards are on his or her deck and how many cards are on the computer's deck. So how can we do this? We just use an F string and we write you have, and right here we are accessing the player associated to the game. We are taking his or her deck, and then we are finding the size of the deck. How many cards are still on the player's deck? Cards on your deck. And we will do the same with the computer player. We write the computer has cell.computer.deck. We access the computer's deck and we take its size. Cards on its deck. But right here you can see that we are getting a warning from PyCharm because we have to fix something in our player class. See if you can determine what we need to fix right here. The message says access to a protected member deck of a class. This is a nice example to review what you have learned so far about public and non-public attributes. Think about this for a moment and then come back. Right here, we are accessing the deck attribute of the player class right here, but this is a protected attribute, so we shouldn't access it, at least not directly. So we have two alternatives. We can either provide a getter for the deck, or we can provide a method in the player class to return how many cards are still on the deck. We could provide a getter for the deck, like this with a property, and we say deck, and we return self.deck, like this. This way, we are providing a way to access the deck in another class or in another part of the program. And we will not modify it because we are not providing a setter for that attribute. Now, if we go to our class right here, we can just replace this with the name of the property, deck, right here. And we see that the warning is gone because we are no longer accessing the non-public attribute or the protected attribute directly. We are accessing it through the property, through the getter. And right here below, we are going to write 4 dashes. We have our print stats method, and we also want to define a method to print a welcome message. We will copy this format that we have right here, and then we will write this, war card game. You could also say, for example, welcome, it's great to have you here, or anything you like. Awesome! Can you believe that we already have our war card game class implemented? We have all the main functionality and logic of our game implemented and represented in this class. So we will just have to write very short code to implement it in our main file. Right here we have init, we can make the initial decks, we can start a battle, we can get who won the round, we can get all the cards that were won by the winner, and we can add cards to a particular character, start a war, check if the game is over, print statistics, and then print the welcome message for the game. In the next video, we will implement the game's main logic, and you will be able to play with your game. So, see you in the next video. Welcome back to this final phase of our project implementation. Now we will write the main logic of the game using the classes that we've defined. We have our card class, our deck class, our player class, our suit class, and our word card game class. We will write the main logic of our code in a new file called main.py. First, to access our class, we will have to use import statements to access each one of the classes that we have defined. So we say from suit import suit. The first name is the name of the file, and this one is the name of the class that we want to import. Then we say from card import card. Then from deck import deck. From player import player. And from war card game import war card game. Okay? So these are all the import statements that we need to implement our code. Let's start by creating the player and the computer instances. We say player, player, and if we go to our player class, we can see that we need to specify a name, a deck, and whether the player is the computer player. Let's say that the name is Nora. You can customize this with your name. And then we have to specify a deck object. In this case, we can specify it directly. We can create it and write it directly as the argument. And the deck will be initially empty. When we create the deck right here, we can see that in init, we have to specify if the deck is empty or not. If the deck is empty, we have to pass a value. If it's not empty, then we can just leave it blank because false is the default value. And that's it. We have our player instance because its computer is by default false. This one is not the computer player, so we can just omit that argument. Now we're going to create our computer instance, which is also a player. The name will be just computer. And we will also create an initially empty deck. This time we have to specify that the player is the computer player. We can just write true right here, or we could also specify the name of the parameter. I really like to do this in these cases where we have more elaborate arguments because it helps you recognize visually that this is the computer player and to what parameter this argument belongs to. This is what we call keyword arguments. You specify or write the name of the parameter right here explicitly. After that, we need a deck because the game has to have an initial deck with 52 cards. We can create a deck with empty parentheses because we want the deck to be built. We want the deck to have 52 cards. So right here, by default, the value is false. The deck is not empty by default. So we can just write empty parentheses. After that, we have to create the actual game instance. We want to have a war card game associated to the player, to the computer player, and to the deck that we just created. We have our instances, great work. We have our players, we have our deck, and we have our game. So how are we going to make this work? First, we want to take the game and we want to print a welcome message. We will be calling this method that we defined right here below. Print welcome message. And then, let's see this logic. We say while it's not the case that the game is over, remember that this returns false if the game is not over. So by adding the not, we are continuing the process. We are negating that value and we are continuing the loop. While the game is not over, then what are we going to do? We're going to start the battle and then we are going to print the statistics. Remember that we said that the statistics were how many cards were on the players and the computer stack. Well, that will be an added value to the game to make it more interactive. And we're also going to ask for user input to ask the user if he or she would like to continue the game, to make this a little bit more interactive as well. And we say, are you ready for the next round? We add a new line character and we say, press enter to continue. Enter X to stop. Okay? The user has to press enter to continue the game or enter X to stop the process. After we have that input from the user, we can check if the user chose to stop the process. We're going to get the lowercase version of the input in case the user enters X as an uppercase letter or as a lowercase letter. That will be equivalent. So we say if the answer was X, then we just need to break out of the loop. We stop the loop and the game ends. We also end the game if the game is over, if one of the players wins all the cards. Excellent work so far. Now we've really implemented our card game. We have all the classes right here. And right here, I added something to show you that PyCharm can be a really helpful tool for this. If we go right here to the top of the file, we see that these two import statements appear in gray. That is because we are not using suit or card anywhere in this file. So we can just delete them and only keep the import statements that we are using. Those are the classes that we need for this file. Finally, let's save our file and run the main file right here. We right-click on it and then we say run main. Right here we see the output. War card game. This is the welcome message that we are printing right here. Then we say let's start the battle. Your card was a jack of clubs. The computer's card was a queen of clubs. The computer won this round because the queen has a higher value than the jack. You can see right here that the symbols are really nice. And we see, these are the stats. You have 25 cards on your deck. The computer has 27 cards on its deck because the computer won the 2 cards that we had right here. And we see, are you ready for the next round? Press enter to continue, enter X to stop. We press enter, and we see another round right here. Let's start the battle. Your card was an ace of hearts, and the computer's card was a queen of hearts. You won this round because the ace is the card with the highest value. Now we see the stats again. You have 26 cards, and the computer has 26 cards. Are you ready for the next round? Let's see. We start another battle, and we see ace of diamonds was your card, and the computer was 10 of spades. So you won this round. Now you have 27 cards on your deck, and the computer has 25 cards on its deck. If we enter X right here, we just stop the process and the game stops. We can continue as much as we need to. And if there is a tie, we will have the war. Let's run the file again and continue until we get a tie. But remember that this is random, so perhaps we will not get a tie until after a few tries. We will press enter, then enter again, then enter again, enter again. So far, we haven't had a tie. Remember that this is random, so we have to wait until the 2 cards have the same value. Right here, we see a tie. This is an example of what happens when we have a tie. Let's start the battle. Your card was 8 of spades, and the computer's card was 8 of hearts. So we see it's a tie, this is war. We have 6 hidden cards that were drawn, 3 from the player's deck and 3 from the computer's deck. We start the battle again. Your card was 7 of hearts and 9 of diamonds, so the computer won this round. What happens? The computer won 1, 2, 3, 4, 5 cards. Previously, you had 33 cards on your deck in the previous step before the battle and the war started. And now, after the war has been completed, you have 28 cards on your deck. You lost 5 cards. And previously, before the war started, the computer had 19 cards on its deck. Plus 5, that would be 24. And that is exactly what the computer has on its deck right now. So this is an example of a tie. That is really awesome. And when one of the players runs out of cards on the deck, then the game will stop. But since this is random, it might take some time. We can test this by removing the input right here. Okay? We can test this by removing the input and just letting the loop run on its own. And the game will stop when the game is over, when one of the players runs out of cards. Let's test this. Right here, you can see that it took the game several rounds of battles and wars to reach right here the game over. You have 0 cards on your deck, the computer has 52 cards on its deck, and we see it right here, game over. Try again, the computer won. So this is an example of what happens when we have a game over. But asking for user input makes the program more interactive and it enhances user experience. Awesome work so far! Try to remember what you knew about this when you started the course. And now you are implementing your very own card game using all the principles that you've learned with object-oriented programming. I really hope you liked this project and you found it helpful. I will see you in the next section to continue learning more about object-oriented programming. This is a fascinating topic and there is a lot to learn, so I'll see you there.